So, students, today we will discuss the bridge, AC bridge. The name of the bridge is the Desauty bridge. It is called the Desauty bridge. This bridge is called the AC bridge. Means that this bridge is working on the supply that is called the AC supply, and this bridge is called the AC bridge. And this bridge is used to find out the capacitance value. Okay, means this bridge is used to find out the value of the capacitor. We will find out the value of the unknown capacitor with the help of this bridge. So we will find out the value of the capacitor C1. Means with this bridge, with the help of this bridge, we will find out the value of the capacitor C1. And the C2 capacitor is the known capacitor. This C2 capacitor is the known capacitor. R1 is known, R2 is known, and means C2, R1, R2 are the known values. These are called the known values, and C1 is the unknown capacitance. Okay, C2, R1, R2 are called the known values, and we will find out the value of the C1. C1 is the unknown capacitance. We will find out the value of the C1, and this bridge is called the AC bridge. Okay, so when the bridge is balanced, okay, so when our bridge is balanced, okay, balanced bridge means bridge is balanced means this detector is showing the zero reading. Okay, when the bridge is balanced, this detector is showing the zero reading, means no current will be flow from this detector. No current will be flow from this detector. Means if from the R1, if I1 is current is flowing from the R1, okay, I1 current is flowing through the R1, means from this detector zero current is flowing, and same current I1 will be flowing from the C1. Okay, because at the balance condition this detector is showing the zero reading, and I1 current which is flowing from the R1, same current is flowing through the C1, and the I1 current is flowing. Okay, similarly at this R2, I2 current is flowing. Okay, I2 current is flowing, and same this detector is showing the zero deflection, and the same current is flowing through the C2 capacitor. Okay, so at the balanced condition, I1 R1 is equal to I2 R2. Okay, means this V1 voltage or this V2 voltage are equivalent. Okay, this V1 voltage and V2 voltage are equivalent. So according to the Ohm's law, V is equal to I into R. Okay, so I1 R1, this V1 voltage is across this R. This is the V1. So V1 voltage across equal to this V2 voltage. I1 R1 is equal to I2 R2 at the balanced condition. Okay, so now these two arms voltage are also equal. Okay, so this arm voltage we will say that the V3 is equal to V4. Okay, though both the capacitor voltages are equal, so we will write down the minus j omega C1 I1. So the voltage across this capacitor C1, okay, the voltage across this capacitor C1, it is given by I1 current is flowing from this arm. Okay, I1 C1 is the capacitive reactance. We will write down the minus j omega C1. Basically, why I have written here minus j, we will write down the xc. Student, here I am explaining xc is equal to 1 upon j omega c. Basically, xc is the capacitive reactance. It is written by 1 upon j omega c1. Okay, but if I am multiplying and divided by the j, okay, this is the j square and j omega c1. This will equal to the minus j omega c1. So this j square is equal to the minus j omega c1. Xc is equal to minus j omega C1. Okay, so we will write down here, this is the I1 minus J omega C1 equal to I2 J omega C2. So this is the equation for the this is the I1 J omega C1 is equal to I2 J omega C2. Okay, so these two voltages are equal when the bridge is balanced. Okay, so I1 J omega C1 is equal to I2 J omega C2. Here is the negative sign. Okay, so now we will dividing this equation means first, this is the equation second. We will divide the equation 1 and equation second. So when I am dividing this equation first and with the equation second, I will get I will get the equation R1 J omega C1 is equal to R2 J omega C2. So from this equation we will find out the value of C1 is equal to C2 R2 divided by R1. So this is the value of the unknown capacitance. C1 is equal to C2 R2 divided by R1. So this is the value of the unknown inductance. So basically what we have done in this bridge, basically we have taken the balance condition of the bridge. At the balance condition of the bridge, V1 is equal to V2 and the V3 is equal to V4. So we have put the value of V1. V1 is the voltage across this arm, that is the between the arm A and arm B. So A or B arm voltage across is the I1 into R1. Okay, then across the voltage B, A or D, that is the I2 R2. Then B, C, we will take the voltage V3. This is the V3. This is over V4. This is over V2. So we have find out the value of the voltages equal. Then separating the real or the imaginary part, we will find out the value of the unknown capacitance. So this is the Desauty bridge, and this is used to find out the value of the unknown inductance. So again, I am repeating, there are the two methods to solve this balanced equation, balanced bridge equation. First method is the impedance of the opposite arm, multiplication of the impedance of opposite arm, means this is the Z1, this is the Z4. Okay, the multiplication of these two arms is equal to the impedance of this two opposite arm. So these are equal. This is the first method to solve the bridge equation. Second method to solve the bridge equation means the voltage across this arm and the voltage across this arm, these are equal. Okay, the voltage across this arm and the voltage across this arm are equal, and we will put the equation V1 is equal to V2 and V3 is equal to V4, and according to the Ohm's law, V is equal to IZ. This is the impedance. Why I have taken this impedance? Because there may be a resistance, there may be a capacitance, or the combination of resistance or capacitance or resistance or inductance. So V is equal to IZ. So we are putting here I1 R1 is equal to I2 R2. Then according to the this balanced equation, we have put the equations here like a V3, V4, And now after putting the values here, we have divided the equation first and the equation second, and we will find out the value of the unknown capacitance C1. But there is the drawback in this method. This Scotty bridge is having the some drawback. Okay, what is that drawback? Because it is difficult and impossible to obtain the perfect balance. Means here we are using the two capacitors C1 and the C2 capacitors. Okay, in this bridge we are using the two capacitor C1 capacitor or C2 capacitor. So there is the problem in this bridge to balance this bridge. Okay, means there is the problem to balance this bridge because we are using the two capacitors, and if the both the capacitors are not free from the dielectrical losses, and then it is difficult to obtain the balanced, because we are using the two capacitors C1 and C2, and it is impossible to balance this bridge. Means the detector is showing the zero reading. Why? Because when we are using the capacitor, there are the dielectrical losses. Okay, means there are the dielectrical losses or air capacitor losses is obtained. So according to this problem, means capacitor is having the problem of dielectrical losses or air capacitance losses. So there is the difficult to obtain balanced condition of the bridge. Okay, means the detector is showing the zero reading. It is impossible to showing this difficulty showing this reading. Okay, so it is difficult to obtain this capacitor reading. Means the detector zero reading. So to overcome this drawback, we are using the modified D-Scotty bridge. Okay. So what is the modified D-Scotty bridge? What we have done in the modified D-Scotty bridge, we have modified these two arms. Okay. These two arms we have modified in the modified D-Scotty bridge. What modification we have done in this like a bridge? We are having a here we are having a R3 resistance, then capacitor. Okay, then again one resistance. Okay, when the overcome this drawback, means when we are using the capacitor, it is difficult to show this detector zero reading. So to overcome that drawback, we have modified this D-Scotty bridge. So what modification we have done in the D-Scotty bridge? We have applied, this is the R1, this is the R2 resistance, this is the R3 resistance. We have added the series resistance with the capacitor C1. Okay, so this is the capacitor C1 unknown capacitance. We have added the R3 resistance. R3 resistance is the series resistance. We have added the series resistance R3, and one, this is the R1 resistance also added. Similarly, we have added here in the fourth arm, we have added one resistance, then capacitance, then again resistance. Okay, so this is the R4, this is the C2, this is the R2. Okay, so we have added these resistance. Okay, so this is the R4 resistance, this is the C2 capacitor, this is the R2 resistance. So what is basically small R1 and the small R2? These are the losses component of the capacitors. Okay, so small R1 and R2 are the this small R1 and this small R2. These are the resistance of the these are the resistance that represent the losses of the capacitors. Basically, we are facing in the D-Scotty bridge, we are facing the problem of the like a capacitor are having the losses, dielectrical losses, air capacitance losses. So to overcome that kind of losses, we are representing here resistance R1 and R2. So these resistances are representing the losses of the capacitor. So what are this representing? These are representing the losses component of the capacitor. So what is the this is the modified Desauty bridge. So this is the modified Desauty bridge, and Desauty bridge. So what we have done in the modified Desauty bridge, basically we have added the R3 and R4 as the series resistance. These are the series resistance. R3 and R4 are the series resistance. Then R1 and R2 are the losses of the capacitor. Means these resistance, small resistance, these R1 and R2 are called the small resistance. Okay, what is this R1 and R2? These are the small resistance, and these resistance are representing this R1 and this R2 are the small resistance. These are representing the losses of the capacitors. Means the losses of the capacitor component are represented by these capacitors. So this is the modified Desauty bridge. Okay, so we will find out the value of the like a balanced equation. We will find out the value of the C1 and the R1. Okay, so now we will write down the equations, like we will write down the V1 voltage, V2 voltage, then V3 and V4. Then we will write down the balanced equation of this bridge. First we will write down this V1 is equal to V2. This voltage are equal, same on the same pattern which we have used in the Desauty bridge. Means this V1 voltage is equal to this V2 voltage, and this voltage across the third arm, this is equal to this voltage. So what we will do now, we will write down the equations of this bridge. So the equation of this bridge is similar to that of the like a Desauty bridge. It is the V1 is equal to V2. So I1 R1 is equal to I2 R2. This is the I2 current is flowing from this R. So at the balanced condition, balanced V1 is equal to V2. So V1 according to the V1 is equal to I1 R1 is equal to I2 R2. Okay, according to Ohm's law. Okay, so V1 is the voltage across this arm. This is the I1 R1. This is the I2 R2. Then we are having a V3 is equal to V4. V3 is the voltage across this arm. V4 is the voltage across this arm. So we will write down the current that is flowing from this arm is the I1. From this arm, current is flowing to the I2. So we will write down the equation I1, I2. So V3 is equal to I1. This is the R3 plus R1 minus J omega C1. So how I will write down this equation? This is the R3 resistance and a capacitor and R1. These are in series basically. So we have written R3 plus R1 minus J omega C1, because this is the, we will write down the R3 plus R1 plus XC. So XC is our minus J omega C1. Okay. So this is the R3 plus R1 minus J omega C1. This is equal to the equation I2 R4 plus R2 minus J omega C2. So we have to find out the value of the C1. Okay, we have to find out the value of the C1. So this is the equation. Now we will divide it. This is our first equation. This is our second equation. We will divide it the equation first with the equation second. This time we will divide. Okay, to simplify this equation, we will divide equation second by equation first. Okay, we will divide the equation second by the equation first. So this is the R3 plus R1 minus J omega C1 divided by R1 is equal to R4 plus R2 minus J omega C2 divided by R2. So we are getting this equation. So this is the J omega C2 divided by R2. So this is the equation. Now we will solve this equation and we will find out the value of the R1 and the C1. So I am solving this equation. R3 plus R1 we are having this equation. Now from this equation we will do the multiplication and the solve this equation. So we will find out the value of the C1 capacitance is equal to R1 R2 C1. We are getting this expression. Okay, so next we will find out the expression like for the resistance. So the resistance R2 is given by, that is the R2 R3 plus R1 minus R1 R4 divided by R1. So these two expression you will getting after solving this equation, you are getting the expression of C2 and the R2. So in case in the starting I told you that we are in the first Desauty bridge we have find out the value of the C1. Okay, but in this bridge we have find out the value of the like a C2 and the R2. So in the numerical, if the numerical is given to you in the exam and if the examiner asks you a question that find the value of the unknown capacitance with the help of Desauty bridge, so they must given the value of C1 or R1. Sometimes they must say that these two values are given, find out the value of C2 or R2. So this is the expression is common. Either from C1 or C2, one value is given to you in the numerical part and the second value you have to find out from this expression, either from this expression C2 or R1, R2, C1 or R2 you will find out from this expression. So note down these two expressions. These two expressions are used to find out the value of the unknown capacitance and the resistance. Okay, so these values are very important from the numerical point of view. So any doubt to any student regarding this modified Desauty bridge. So students, in the exam you have given the numerical, like this diagram is given to you, and the question is the find the value of C2 or R2. Maybe in the exam question is came like this one. These values are given to you and you have to find out the value of C1 and R1. So then you will rearrange this equation. So now we will find out the value of C2 and R2. So we are having the formula of C2 is equal to, that is the C1 into R1 divided by R2. Okay, so we have put the value of C1 is the 1 into 10 the raised to power minus 6 farad, because this value is the 1 microfarad. So R1 is the 1000 ohm, R2 is the 1000 ohm. So we have put these values, and the value of the C2 is the 1 microfarad. Okay, then we have to find out the R2 value also. These are the losses value of the capacitor C2. Okay, so this is the R2 into bracket R3 plus small r1 minus r1 into R4 divided by R1. So you will put these values. R2 is the 1000 ohm, 2000 plus 10 minus 1000 into 2000 divided by 1000. So when you will solve these values, you will getting R2 is equal to 10 ohm. So this is the value of the R2 resistance. In some questions, examiner also say that he find out the phase angle error also. So the formula of the phase angle error, that is the delta 1 is equal to omega R1 C1. So omega is the 2 pi f frequency. Frequency is given in the numerical, and similarly you will find out the delta 2 also, that is the phase angle error second. Okay, so that is the omega R2 C2. This is the omega R2 C2. In some question or in some numerical they will ask you find out the phase angle error 1, phase angle error 2. So the formula of the phase angle error 1 is the delta omega R1 C1, and the formula of the phase angle 2 is the delta 2. So phase angle error is delta 1 is equal to omega R1 C1. Similarly, delta 2 is the omega R2 C2. So in the numerical, if you will find out the value of delta 1 and delta 2, frequency is given in the numerical, that is the 1000 hertz. Okay, this value is given in the numerical part. Then you will put the delta 1 is equal to 2 pi f1 r1 c1 value here. Then you will find out the value of phase angle error 1, then phase angle error 2 also. Okay, so this is about the Desauty bridge. Any student having any doubt regarding this numerical, regarding this bridge? So student, this is the last bridge of your topic, unit number first, that is the Wien bridge. And this bridge is used to find out the value of the frequency. Means this bridge is used to find out the value of the frequency that we are using in the circuit. Okay, so this bridge is the important because this bridge is used to find out the value of the unknown frequency. Okay, so this bridge is having a specialty to find out the frequency, unknown frequency. So again, this bridge is having the 4 arms, A, B, C and D are the 4 arms. Okay, so these are the 4 arm basically, and R1 resistance is the variable resistance. So arrow is here like this one. R3 resistance is also variable resistance, and this bridge is used to find out the value of the unknown, means a frequency. This is bridge is basically used to find out the value of the frequency. Okay, so now what we will do, we will find out the value of the Z1, Z2, Z3 and the Z4. Impedance of the arm first, impedance of the arm second, impedance of the arm third and impedance of the arm fourth. Okay, then we will apply the formula that we have Z1 Z4 is equal to Z1 Z4 is equal to Z2 Z3. We will apply this formula. Okay, so first of all we will find out the Z1, that is the, it is in the series, so R1 minus J omega C1, because these R1 and the capacitor are in the series. So you can write down also this one, R1 plus 1 upon J omega C1. Okay. So when I am writing R1 plus J square omega C1, this J square is equal to minus 1. So this is the minus J omega C1. So instead of writing this R1 plus 1 upon J omega C1, I will write down the R1 minus J omega C1. So these two are equal. So I am writing here R1 minus J omega C1. Okay. So next we will write down the value of the Z2 is equal to, this is the Z2 is the R2, only the resistance R2. Z3 we are having the R3 is in parallel with the C3. This R3 is in parallel with the capacitor C3. So we will write down the R3 upon 1 plus J omega C3 R3. So we will write down R3 upon 1 plus J omega C3 R3. This is the impedance of this R. Okay, Z4 is the R4. So now putting, we will first of all we will find out the impedance of Z1, Z2, Z3, Z4. Four resistance, four impedance of the four arms. We will find out the impedance of the four arms. Then we will putting these impedance of arm first, arm second, arm third, arm fourth into this equation. Z1, Z4 is equal to Z2, Z3. This equation we have derived from the AC bridge, and previously we are using this equation Z1, Z2, 4 is equal to Z2, Z3. So it is basically multiplication of the opposite arm. This is the Z1 multiplied with the Z4 opposite arm. Then this R3 opposite arm is the R2. We will multiply these two. So we will find out the equation like Z1 and the Z4, R1 minus J omega C1 R4 is equal to R2 R3 divided by 1 plus J omega C3 R3. So we are having this equation. Now we will solve this equation, and we will do the cross multiplication first of all. Then like we will find out the value of the equation. We are having a R4 R1 minus J omega C1, then 1 plus J omega C3 R3. We will do the cross multiplication of this denominator with this numerator. Okay, is equal to R2 R3. Now student, you will solve this equation part. Okay, so we are having this R1 R4 minus J R4 omega C1 1 plus j omega C3 R3 is equal to R2 R3. Now we have multiplied this R4 with this bracket inside bracket. This is the R4 multiplying with this one. So this is the R1 R4 minus j omega R4 into this one. So now we will again multiplying this equation with this one, and then we will do the separating the real and the imaginary part. Then you will, students, you will getting the equation like this one: omega square is equal to 1 upon r1 r3 c1 and c3. We are getting this equation. From this equation we will find out the value of the frequency, that is the f is equal to 1 upon 2 pi under root r1 r3 c1 c3. So this is the expression of the frequency of the Wien bridge. Means first of all we will write down the impedance of Z1, Z4, Z2, Z3. Then from then we will do the cross multiplication of these two equations. From these two equations we will find out the value of the omega, that is the frequency value, and frequency value is the 1 upon 2 pi under root r1 r3 c1 c3. So this is the Wien bridge. Wien bridge is used to find out the value of the unknown frequency basically. So